Lesson 4.2, Remainders when whole numbers don't divide evenly. We can use models to divide whole numbers that do not divide evenly. 6 divided by 2 divides evenly. We have 6 counters. We can put them into 2 groups evenly. 7 divided by 2 does not divide evenly. When we try to put 7 into 2 equal groups, we end up with 1 left over. We can divide counters evenly into groups. Sometimes counters will be left over. The dividend is how many in all. And the divisor is how many groups we have. We have 2 groups. And the quotient is how many in each group. We can also look at the divisor as how many in each group and the quotient as how many groups. Sometimes we'll have a leftover amount because we can't divide evenly. The leftover amount is called the remainder. 7 divided by 2, we have 7 counters that we put into 2 groups. We have even groups, they both have 3 in them, but we have 1 left over. That's the remainder. 7 divided by 2 is equal to 3 in each group with 1 remaining. It's equal to 3 remainder 1. We can also write 3 with an R and then a 1. We can use the letter R for remainder. 5 friends want to share 21 pieces of candy. To be fair, each friend wants to receive the same number of candies. Can they divide them equally? We can model the problem by using 5 circles for the 5 friends, and we have put a counter into the circles one at a time to make them even. We'll put 1, 1, 1. See how we're doing it one at a time? That way we know we're putting an even amount into each circle for each friend. We keep repeating this. So far they each have 3 candies. Now they're each going to have 4 candies. Each friend has 4 candies, but look, we have 1 candy left over. We count how many counters are in each group. There are 4 counters in each group with 1 left over. 21 divided by 5 is equal to 4. We have 1 left over, so we have remainder 1. 4 remainder 1. When a number cannot be divided evenly, the amount left over is called the remainder. We can use drawings to find 30 divided by 7. We can use open circles or tally marks as the quickest way to draw. You don't want to make drawings for each counter that take a long time. If you were taking a test and putting counters on your scratch paper, you would waste all your time drawing the counters and you'd run out of time for your test. So let's make some open circles or tally marks. Let's do open circles in this one. So we have 30 and we need to divide it into 7 equal groups. So we start by putting 1 in each group. 1, 2, 3, 4, 5. Oops, let's close that one. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Uh-oh, if I do 29, 30, then they're each going to have 5, and they're only going to have 4, so I have to stop. We share the counters equally among the 7 groups. The number of counters in each group is the quotient. So we have 4 in each group. But we only got to 4 times 7, which is 28. And the number of counters left over is the remainder. So we have 28, 29, 30. We have 2 left over. 30 divided by 7 is equal to 4, remainder 2. If the remainder is greater than the divisor, remember that's the divisor. So if the remainder is greater than the divisor, there are more counters that can be shared equally. So this was done wrong. There's 16 counters. We're doing 16 divided by 5. There's 16 counters. They put 5 into 2 groups and said that the answer is 2 remainder 6. But the remainder is greater than that 5. That means we could have made one more group. The correct way would have been to have 3 groups of 5 with 1 remainder. Whenever the remainder is greater than the divisor, we can make another group. Or we could put more into each group. Use a quick drawing to find the quotient and the remainder. Open circles or tally marks are faster. Here we have 13 divided by 2. So we made 2 circles for 2 groups, and we need to go back and forth and put 13 in them. So we're going to start. We're going to use tally marks this time. We have 1, 2, 3, 4, 5, 6, 7, 8. We can cross this for 9, cross this for 10, 11, 12. If I put the 13 in this one, then this one will have 7 and that one will only have 6. So we stopped at 12. We have 2 groups that each have 6 in them, and we have 1 left over. 13 divided by 2 is equal to 6, remainder 1. Here we have 15 divided by 4. We can start by putting tally marks into our 4 groups. We put 1 in each group, so we do it evenly. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I do 13, 14, 15, that won't have enough. So we stopped at 12. We have 3 in each group, and we count on 12, 13, 14, 15. We have 3 left over that couldn't fit into the groups. We have 3, remainder 3. We can think of the multiplication facts we know to quickly decide if a division equation will have a remainder or not. We have 33 divided by 8. So we think, well, 8 times 4 is 32. We think of our 8 facts. That would fit, and we would have 1 remainder. Yes, that does have a remainder. We have 42 divided by 7. We think of our 7 facts. 7 times 6 is equal to 42, but that's exact. That's the exact product. So no, there's no remainder. We have 57 divided by 6. We think of our 6 facts. We think, well, 6 times 9 is 54. If I did 6 times 10, that would be 60. That would be too much. That would be too great. So that would fit, but then we have 3 left over, 3 remaining. So yes, that would have a remainder. Tala is making necklaces to sell. She has 76 beads and puts 10 beads on each necklace. How many necklaces can she make? So she has 76 beads, and we need to divide it into groups of 10 so she could put 10 beads on each necklace. Then we need to find how many necklaces she can make. And we think, well, 10 times 7 is equal to 70. So we know she can make at least 7 necklaces. But then she'll have some left over, won't she? So how many more beads does she need to make a total of 8 necklaces? We think, well, 10 times 7 is equal to 70. She's got 76. That means 6 are left over. She needs 10 for each necklace. If we subtract the 6 she's got left over, we know she needs 4 more beads. We can also think of it as 10 times 8 equals 80, and that in order to make 8 necklaces, she would need 80 beads. And we subtract the 76 that she has from the 80 and know that she needs 4 more beads. We got the same answer, but we found a different way to get it. There's usually more than one way to solve a problem. Some ways are just faster and easier. We need to use mental math and counting on to find the quotient and remainder. Here we have 17 divided by 3. We need to find how many times the 3 will fit into the 17. Using mental math, we think, well, 3 times 5 is 15. And we can't fit another 3 into here, because then it would be 18, right? So we have 3 times 5 is equal to 15. And we've got 16, 17. We've got 2 left over, so it's 5 remainder 2. Here we have 39 divided by 9. Well, we can use mental math and think of our math facts. 9 times some number is close to 39. 9 fits into 39 how many times? When we think of our basic fact, 9 times 4 is equal to 36. So we know it can fit in at least 4 times. And if we count on 36, 37, 38, 39, we have 3 more. We have a remainder 3. So we can use basic math facts that we already know and count on to find the remainder. Here we have a riddle. It says, for the clues, my divisor is 8. Okay, well, we know the divisor is 8. And it says, I am less than 30. So we know that whatever we're looking for is less than 30. It says my quotient is 3. So we know that's a 3. And it says my remainder is 5. So we know we've got a remainder of 5. What dividend am I? So we're looking for this dividend. We know the divisor's 8, and we know whatever this dividend is, we know it's less than 30. We know the quotient is 3, and that there is going to be 5 left over. So we think 8 fits into some number. 8 fits into some number 3 times, with 5 remaining. We think, well, 8 times 3 is equal to 24, and if there's 5 remaining, we add 5. So we know it fits into 24 3 times, but because there's a remainder of 5, we had to add 5. Do you know what the number is? If you said 29, you're right. And if you have trouble figuring out riddles like this, you can even try guess and check to see if the dividend you come up with or the missing number you come up with fits into the problem. 8 times 3 is 24, but it doesn't fit evenly. We can count on, we have our 3, 8 times 3 is 24, 24, 25, 26, 27, 28, 29. Yeah, if we had 5 left over, the dividend would be 29. So we know the answer is 29. Here we need to write equations that will fit each drawing. We've got 1, 2, 3, 4, 5, 6 groups. We can see there's some left over. We need to know first how many are in all. We have 4, 8, 12, 16, 20, 24. We can also see there's 4 in each of these groups and do 1, 2, 3, 4, 5, 6 times 4 is equal to 24. But is that how many are in all? No, we've got 3 over here. So it's not 24, it's 27, isn't it? We have 27 in all. And how many groups did we make? We made 1, 2, 3, 4, 5, 6 groups. And how many are in each group? Well, in the groups, there's 4. And we know that there are 3 left over. We have a remainder of 3. We have 27 divided by 6 is equal to 4, remainder 3. Now let's see if we could do it for this one. We have 6 in each of these groups. That's 1, 2, 3, 4 times 6 is 24. But let's count our remainder this time. We have 24, 25, 26. So we have 26 in all. And how many groups do we have? We have 1, 2, 3, 4 groups. And how many are in each group? We have, in the groups, we have 6. But we have some left over, don't we? They couldn't fit into a group to make even groups, so we have a remainder of 2. This drawing shows 26 divided by 4 is equal to 6, remainder 2. Just remember, when you're writing your dividend here, that you count all of the counters, even the ones that aren't in groups, because we need to know how many are in all. So a division problem can be written like this, 16 divided by 5. And it can also be written like this. This is 16 divided by 5. Either way, they mean how many 5s are in 16. We have 1, 2, 3, and we have 1 left over. That would be 3 5s. So our answer would be 3 remainder 1. It also means 16 divided into 5 equal groups. We still have 1 left over. Or 16 with 5 in each group. See how we still have 1 left over? So we have to be comfortable looking at division problems written like this, 16 divided by 5. And we're going to get into this more in video 4.10. This is only video 4.2. We're only at the beginning of chapter 4. And this is going to be about long division and placing the first digit in the quotient. But when you see this, you need to think, how many times will this 5 fit into that 16? We think 5 times 3 is equal to 15, so we know it'll fit in 3 times. Well, 5 times 4 is 20, so it won't fit in 4 times, but it will fit in 3 times. And we write the 3 above this dividend, above the 16, but because it's 3 ones, we write it in the ones place. See? We're fitting the 5 into both digits, the 16. We're not fitting it into just the 1, see? It won't go into the 1. We're fitting it into the 16, so we put the 3 there. Then we multiply the 5 times 3, and we write the product below the dividend right here. 5 times 3 is 15, and we subtract. We get 1. That's how we get 3, remainder 1. And we're going to talk about this more in video 4.10. Many students get very confused doing long division, and I wanted to give you a little preview of what's going on so that you'll be more familiar with it when we get to video 4.10. In our next lesson, 4.3, we're going to interpret the remainder. We're going to be using the remainders. And I hope you're doing well. Keep trying, and I'll see you next time. Bye.